Hello everyone, welcome to Wings of Physics. Myself Deepali Kulkarni from PVP Junior College, Pravaranagar, Loni. We will continue our topic thermodynamics and today's lecture is lecture number 13. In this lecture we will study the refrigerator, AC means air conditioner and heat pump. Okay, let us start. What is refrigerator? Refrigerator is also called as a fridge. That is very useful device in our kitchen because it makes our life easy. And refrigerator works on a principle of a heat engine but a reverse heat engine. In heat engine what happens? Heat flows from hot region to cold region or hot reservoir to cold reservoir and work is done by the system here, and that is the natural tendency of a heat to flow from higher temperature to lower temperature, and in this case heat get converted into the mechanical work. This is about the heat engine and this is a spontaneous process. This is about a heat engine and that is a spontaneous process, and in case of a fridge we have to transfer the heat from colder region to hotter region. It is not a natural process, it is non-spontaneous process, and to transfer heat from colder region to hot region we have to do work on this system with the help of a compressor which is present in a refrigerator or fridge, and means we have to convert the mechanical work into the heat, means exactly opposite to the heat engine, and on this principle the refrigerator work. Suppose a water is present at higher level and we have to transfer this water from higher level to low level. We can transfer it easily because that is a natural process. But if we have to reverse the flow of this water, means we have to transfer this water from lower level to higher level, it is not possible. For that purpose we have to use a motor, and by using motor we apply a force. Due to that force, displacement of that water is there and due to that work is there. Means in this case we convert the mechanical work into the heat. Like that in refrigerator we have to transfer heat from colder region to hotter region by doing work. Okay. Now we have to study about the refrigerator. Before that we have to study what is refrigeration. Refrigeration, that is nothing but a artificial cooling of a space or a substance of a system, or to maintain the temperature of a substances below its ambient temperature. What is ambient temperature? Ambient temperature means room temperature. This is the inner part of the fridge and we have to cool these substances. For example, if vegetable is kept in that fridge or milk is there, some cold drink is there, at that time we have to cool that substances below the room temperature. That is the ambient temperature, and means the refrigeration, that is nothing but a artificial cooling. That is not a natural cooling. Refrigeration means the artificial cooling of a substances. Then we have to study the mechanism of the refrigerator. For that, we have to consider the schematics of a refrigerator. This refrigerator consists of three main parts. First is expansion wall. Second one, that is compressor. And third one, that is a closed tube. This is a closed tube or a coil through which a refrigerant is flowing. What is a refrigerant? Refrigerant, it is a fluid form. Fluid, what do you mean by fluid? A substance, fluid, a substance which is capable of flowing, that is called as a fluid. Means all gases and all liquids, they are considered as a fluid because they are capable of flow, and therefore refrigerant is a fluid, and that is in both the form present in case of a refrigerator. It is present in liquid form as well as gaseous form, and a fluorinated hydrocarbon that is used as a refrigerant in case of a refrigerator. Now, this is the hotter region. Red region, that is a hot region, and violet region, that is a cold region. Then this refrigerant, it is in liquid form in the hot region, and it is in gaseous form in the cold region. Okay. Now, we have to study the mechanism. For that, we have to consider the 4 steps. Step first. What happened? Just now I told you the refrigerant is in liquid form in the hot region. Then when this liquid refrigerant enters through this expansion wall, through this nozzle, at that time it gets expand, and during that case no heat enters or leaves through the system, and when Q that is equal to 0, no heat enters or leaves through the system. At that time the process is called as adiabatic expansion, and when adiabatic expansion is there, temperature decreases. Means this liquid form refrigerant that get transferred in the gaseous form, and it enters in a low pressure region. This is the inside part of the refrigerator or fridge, and inside the refrigerator pressure and temperature is low. Always keep in mind that the pressure and temperature in this region or inside inner part of the refrigerator, that is always low, and the liquid refrigerant that gets converted in the gaseous, and its temperature is negative, okay, near about -10. Then this is the first step, that is nothing but a adiabatic expansion. Step first, that is adiabatic expansion. Adiabatic expansion. And in expansion wall, forced vaporization is there. What is forced vaporization? Forced vaporization means liquid refrigerant that gets converted into the gas, and its pressure and temperature becomes lower. Okay, this is the first step. Then now what happened in second step? Step second. In second step, some substances, suppose vegetable, milk, cold drinks, that is kept inside the refrigerator. Then the temperature of these substances, that is greater than this temperature. Okay. Now what happened? The temperature of these substances, that is greater, and temperature of the refrigerant which is in gaseous form, that is lower. Then we know that heat transfer from higher temperature to lower temperature. Means the heat transfer from these substances which are kept in the inner part of the refrigerator, they transfer their heat to this gas. But this process occurs at constant temperature, and during a constant temperature process is called as isobaric process. Means in step second there is isobaric expansion. means heat transfer from these substances to that gaseous form refrigerant. Okay, and evaporated coil is here. This is the inner part of the refrigerator. Then step third. Now this gas comes outside the refrigerator. Then the compressor is there. With the help of compressor, this low pressure gas that gets converted into, when that gas is compressed, at that time there is a forced condensation. Means with the help of compressor, a forced condensation is there. Means a refrigerant which is present in gaseous form that turns into the liquid form, and that is called as forced condensation. And also due to the compression, the temperature that gets increased. Means in inner part pressure and temperature is low, but now when that gas is compressed, its pressure and temperature becomes high, and the gaseous form that gets turned into the liquid form. And means the compressor is very important part of the refrigerator, that we can say that is the heart of the fridge. Okay, and this coil is hot coil, that is also called as a condenser. Now liquid form refrigerant now is flowing in this coil through this hot coil, and step third happens here. That is step third, that is during this compressor, the no heat enters or leaves through the system. Means again in step third, Q that is equal to 0, means this compression is adiabatic compression. Okay, now this liquid is flowing through this coil or through this condenser. Then step 4, when this hot liquid flowing through this condenser, then around that condenser a surrounding is there. Then surrounding temperature of this refrigerant which is in liquid form, that is always greater, that should be greater than the surrounding temperature, and due to that heat flows from this refrigerant to the surrounding, and this occurs at constant pressure. Means again in step 4, isobaric compression is there. Isobaric compression is there. If the temperature of this liquid that is less than the surrounding temperature, then what happen? Heat transfer from surrounding to refrigerant, and this liquid becomes hotter, and that is not useful. And for that purpose we have to increase the temperature of this liquid so that heat is rejected to the atmosphere. This is the reason to use the compressor. Okay, and then heat is rejected and this liquid, the temperature of this liquid becomes low because heat is rejected, and again that is enter in this expansion valve, and the cycle goes on repeating, and in this manner the fridge is working or refrigerator is working. Means heat transfer from this colder region to hotter region by doing some work, means the mechanical work that get converted into the heat, that is nothing but a reverse heat engine. Okay, and this is all about the working of a refrigerator. Are you getting my point? Now the efficiency of this refrigerator that can be measured in terms of COP. What is the COP? COP is the coefficient of performance. COP, that is the coefficient of performance of a refrigerator. It is denoted by letter K, and its formula is QC divided by W. QC is heat absorbed in a colder region, and W, that is the work done. Then K, that is equal to value of QC, and W that is nothing but QC minus QH, because QC is heat absorbed and QH is the heat rejected to the atmosphere. QC is the heat absorbed and QH is the heat rejected, and therefore this is the formula for coefficient of performance of a refrigerator. It is also called as K value, or it is also called as a quality factor. Then for greater performance, value of K should be large, and if K should be large, for that purpose, due to direct proportion, QC for K large, what is the condition? QC should be large, because direct proportion is there, means heat absorbed by that refrigerant, that should be large, and W should be small due to inverse proportion, means work done by this compression, that should be small. Okay, means W should be small, work done small, and this is the condition for greater performance of a refrigerator. Understood? Again, it is the ratio of two similar quantity, and therefore coefficient of performance, that is a unitless and dimensionless quantity. It have no unit, no dimension, and for typical refrigerator, the value of K, that is equal to 5. Okay, our household refrigerator, the coefficient of performance, that is nearly equal to or equal to 5. Then capacity of a refrigerator, that is measures in terms of a liter. Then what is the meaning of capacity? It is the volume available inside a refrigerator. Understood? जर दुकानात आपण फ्रीज घ्यायला गेलो तर आपल्याला दुकानदार विचारतो किती लिटरचा दाखवू, 165 लिटरचा दाखवू, 175चा दाखवू, 300 लिटरचा दाखवू का 275चा दाखवू. याची कपॅसिटी कशात मोजली जाते? लिटर मध्ये मोजली जाते. याच्या आतमध्ये किती व्हॉल्यूम अवेलेबल आहे त्याच्यावर रेफ्रिजरेटरची कपॅसिटी डिपेंड होते. ओके, दिस इज ऑल अबाउट द रेफ्रिजरेटर. ओके, नाउ वी हॅव टू स्टडी द AC. AC मीन्स एअर कंडिशनर, जो उन्हाळ्यात आपल्याला खूप गरजेचा पडतो. AC, एअर कंडिशनर. देन the working of refrigerator and AC, that is same, only difference is that the inside the room evaporated coil is present. आपल्या रूमच्या आतमध्ये AC, ज्या रूमला आपण AC बसवतो तर हा फक्त फ्रीजच्या आतमधला भाग आहे, त्याच्याऐवजी ही आपली रूम कन्सिडर करा. तर evaporated coil is inside our room and compressor is outside the room. Then a fan is there in AC unit. आपल्या घरात जे AC युनिट आहे तिथे फॅन असतो. फॅन कशा करता असतो? तर ही cooled air that is cooled by this evaporated coil, that is circulated with the help of fan which is present in a air conditioner unit. Again, the efficiency of a AC, that is measured by a coefficient of performance, and formula for coefficient of performance or quality factor of a AC, that is also same. Now we can express this formula in terms of H and T. What is the H? H is the rate of heat removed by a working substance. ह्या working substance ची किती heat removed झाली, that is also called as heat current, and that is nothing but किती वेळात किती heat reject झाली. तर H, that is equal to QC by T, आणि त्याच्यावरून आपल्याला ह्या QC ची व्हॅल्यू काय मिळाली? H into T. Now we can substitute value of this QC, that is equal to H into T. Then what is the power to remove this heat? Power, that is nothing but time rate at which work is done, and therefore W, that is equal to PT. And if we substitute value of W, that is equal to PT, then this TT that gets cancelled, and K, that is equal to H by P. Understood? This is the formula to calculate the COP, coefficient of performance of a AC or air condition. Okay, then the capacity of AC, that is measured in tons. जर आपण AC घ्यायला गेलो तर दुकानदार आपल्याला विचारतो किती टनचा AC दाखवू, 0.8 टनचा दाखवू का 0.9 टनचा दाखवू का 1.5 टनचा दाखवू का 2 टनचा दाखवू. मीन्स कपॅसिटी ऑफ AC दॅट इज मेजर्ड इन टन्स, टन मध्ये मोजली जाते. आणि याचा रेफ्रिजरंट विच इज यूज्ड इन केस ऑफ AC दॅट इज R22, दॅट इज फ्रीऑन गॅस, and second one that is R410A, that is puron gas, and that is the refrigerant used in case of a AC. AC साठी हे दोन रेफ्रिजरंट वापरले जातात. ओके, and this is all about the air conditioner. समजलं का? Are you getting my point? And third point, that is the heat pump. Heat pump, that is nothing but a room heater. इट इज यूज्ड इन ए कोल्डर कंट्री, जे थंड प्रदेश आहेत तर तिथं हीट पंप वापरला जातो. कशा करता, तर बिल्डिंगच्या बिल्डिंग हीट गरम करण्याकरता. मीन्स इट इज ए रूम हीटर और इट कॅन हीट द बिल्डिंग्स. फॉर दॅट पर्पज ओनली अपोजिट कंडिशन इज देअर. इव्हॅपोरेटेड कॉईल इज आउटसाइड द बिल्डिंग अँड कंप्रेसर इज इनसाइड द बिल्डिंग. कारण उलट करायचं आहे आपल्याला, बिल्डिंग थंड करायची आहे. त्याच्यामुळं काय होईल, इव्हॅपोरेटेड कॉईल इज आउटसाइड द रूम अँड दी कंप्रेसर इज इनसाइड द रूम इन केस ऑफ ए हीट पंप. अँड इट इज ऑल्सो ए रिव्हर्स हीट इंजिन. अँड दिस इज ऑल अबाउट द रेफ्रिजरेटर, AC and heat pump. Okay, I hope all of you understood these three devices very well. If you like my video, then like, share and subscribe my channel, and also press the bell icon to get notified about my new upcoming videos. Thank you very much.